Hey, good day to everybody. Welcome back to our 2023 Community Day ECL Challenge Workshop. And once again, in case you missed the first hour, where were you? Well, thankfully we have it recorded, so you'll be able to go back and watch it if you did miss it. But in case you did, let me just introduce myself. My name is Bob Foreman, and with me also today in this Hour 2 workshop is Mr. Richard Taylor, who has been an ECL mentor to me for many, many years. And Richard, as the ECL guru, will be monitoring the Q&A channel as well as me, and will be there to answer any questions that you have during this Hour 2 session. So I'm glad you're here. Welcome. And let's jump into Hour 2, which is called Find Your Paradise. All right. So an idea was circling around the HPCC team. Have you ever thought of building an application that can help people find places to live, to maximize your quality of life and your overall pursuit of happiness? So we decided then, after thinking about it, to pull in a variety of different public data sets, put them together, and each data set would be measured as to how well it contributes to your quality of life. And then putting them all together, we can generate a composite scoring system that then will better help you evaluate what place, well, particularly in this example, in this workshop, we're speaking of the United States, but where in the United States you would like to live. So we're going to deliver this data at the end of the workshop via ROXIE, and I'm going to show you visualization as another option. And just to back up a little bit before we get into this, as you know from Hour 1, we are kind of reviewing and revisiting the hackathons and code day challenges that we have done in 2023 across multiple universities in the United States that were very successful. And this challenge we first introduced back in February of this year, and it was well accepted, very popular, and we plan to do it again as well as in this workshop. So again, find your paradise. Let's talk about what we did. Let's get started. And once again, too, that's the idea behind these workshops. We want you that are out there to participate in this challenge, just like the students across the different colleges did, and come up with your own solution of finding your paradise. All right, so the first step was to discuss what data we were going to be working with. And there's a lot of things in life that you measure as a good place to live. So we took, first of all, the low-hanging fruit. Obviously, if you're in an area where there's a lot of crime, it's not a good place to live. So crime, we look for a data set that would measure the amount of crime. And we did find a good data set of crimes between, well, the year 2018 and 2021. I think I also have another data set we're going to be looking at that even goes further and deeper into that. I think we found a data set that went into 1979. The second criteria we thought would be interesting is weather. And the thing I like about weather, especially now, you all know, I mean, we're in October, but you know what a hot and brutal summer we had with record high temperatures and so on. So climate is becoming an important issue more and more each day. And so the National Oceanic Administration at NOAA, we have a set of weather data that is public available, and it goes deep and far back. So we grabbed the sampling of storm events over, well, in this case, it says over the last 10 years. You could go back as far as you want. I think in this example, we used the last 5 years of storm events. And you'll see it was still a pretty hefty data set for just that amount. Number 3, we call health, or more accurately, mortality. So of course, you don't want to live in a place where people are dying younger, you know? So yes, there are statistics about that. There's statistics state by state of mortality over the years. And so once again, we have a public data set that we were able to grab and then process into our HPCC Find Your Paradise Challenge. And then last, I thought that, a lot of people that I know, especially people that are looking to move to a place, they're young parents, they have children. And so education is a big issue as well. So we have had and found a data set of public and private schools, once again by state. And then we looked at the data that was provided by those schools, and we said, what would be an interesting measurement of how good a school may be? One of the things I'd think about is the attention that the student gets. If a student is in a very large class and the student to teacher ratio is very large, a student can kind of be ignored or be excluded from a learning process and not get the attention that they need. So that was an important factor, one of the many important factors that we're going to be looking at: enrollment and student to teacher ratio. All right, so in addition to these 4 data sets that we provided, we gave the students also explicit instructions that they were not limited to these 4 data sets or these 4 categories. And some students actually pulled in other categories. One of the things that's on the mind of a college student, of course, is employment. So they went out to get the unemployment statistics by state and merged that into their Find Your Paradise. So again, this was just kind of a ground zero starting point of 4 categories, but again, there's other categories that people could consider and pull in to this challenge. All right, so now let's once again review the playing field. In hour 1, I also had this slide, and so just a review for those of you joining us for the first time in this workshop, our cluster that we're going to have available for this week during this workshop and through the entire week of the summit is this URL right here. We have a training cloud cluster ready, all set up, ready to roll with all of the challenge data already loaded, already sprayed. All you have to do is go into the repository, check out the data, and start writing your own ECL code from there. On the left side, we have the VS Code configuration for the training cloud cluster. And on the right side, we have the configuration for the ECL IDE. All right, and now let's talk about the repo. Here is the repo. It's called the Find Your Paradise repo. It is public, so you can go out there and clone it and copy what you need from the repo down to your local machine, and then work with the data on the training cloud cluster. And I'll show you, this is the slide, but let's go over to the actual cluster live. Here we are. This is the cluster live called Find Your Paradise. And the code of the interesting code that we have here is the code folder right here. And we're going to go over these examples. I'm going to explain to you what these examples represent in just a few moments. Also on the front page of this Find Your Paradise repo is another explanation of this challenge called Find Your Paradise. So we go through exactly the same scenario on what we're looking for, some resources that are here that we point to, what we're looking for in this challenge. And there's also some of our mentors that help put together this challenge and support. For example, George had produced our wiki page for the challenge, and Richard Taylor, of course, and Ugo, and then some other mentors from our Brazilian team who are also on hand to help. So anyway, this is our README for this repository. And you want to go there, you want to go to the code button, you want to clone it or download the information back to your own local machine, and then work with the ECL code and modify it to your specifications. All right. So now let's take a look at the 4 dataset categories that we presented in this challenge, starting with education. So we divided our education into 2 categories, of course, public schools and private schools. we actually got this data, public data set, free for public use from the Homeland Infrastructure Foundation level data. So the U.S. Department of Homeland Security providing information about schools. And this is under the public domain. Here are the URLs to go get these files. You don't have to do that though, because we already did that for you. But if you actually want to go and see what the source of the data is and go out and get the data on your own, and they do have updates for this periodically, adding new schools to the data set, you might want to go and refresh your data from time to time. These links I will provide in a file that we'll have attached to the workshop in the one of our chat windows there. We'll have the link to these particular URLs. All right, so we have public schools and private schools. Now, what did we do with this? Well, the first thing we did was we wanted to combine public and private schools together, mark each record accordingly. This record is representative of a public school. This record is a private school. Then step number 2 in the challenge, we created a all schools file, which merged public and private together. Then once we merged it into a single data set, we were able to analyze it and rate it based on our own criteria that we chose. For example, student to teacher ratio. And then we built a file that scored the quality of education by state. So the ground rules for this was let's pick state by state level. Let's pick 50 states. And the reason I did that was because of the nature of the data. The nature of the data essentially was built for this. It was built for 50 states. Now we had to do some data manipulation to get all the data lined up from the different categories. That's one of the things we're going to look at. And we also needed to develop a scoring system. So as we were developing the scoring system, we ranked each state from 1 to 50, one being the, one being the highest level of, for example, the lowest quality of schools, and 50 being the highest quality of schools. And then we put those scores together and merge them with the other categories like weather and mortality and so on. We'll take a look at that code together. So let's jump out there to our ECL IDE. Here is the repo for Find Your Paradise. Let me zoom in on that so you all can see that. You can see I've got just a folder I attached to in my IDE. And if you, all of you should know how to do that. You basically go into your preferences of your IDE and you add the ECL folder to your repository. So I went out to my local repo of Find Your Paradise, and I grabbed the code folder that has all of the code examples that we're going to be looking at in this hour. The first one you want to focus on is always just make sure the data is all there and ready to go. So we have a file called browse input data. And so as you can see here, we've got public schools at the top, private schools, crime data, mortality data, i.e. health, and weather, and then a lookup table, which I'm going to explain in just a few moments. So the first thing you want to do when you download this repository and you attach to your cluster, make sure all your data is there. You give this a run, and like I said, the data will be there because in our training cloud cluster, we sprayed this data for you. So all you have to do is run this BWR file and get to know the data. So the first output here, as you can see, is public schools, and we've got a latitude and a longitude, name of the school, address information. So it's kind of a rich data set of school information. But the real value of this data set was at the very end of the record structure, where you see the number of enrollments for each school, and you also see full-time teachers, and well, there's a starting grade and ending grade and so on, and also the level of education that's here. So these were the data points that was interesting to me. But there's all kinds of other data in here that you can then add to figuring out the quality of life. But we wanted to go for statistically, all right, that's the name of a school, great, but how good is that school? How do we measure the quality of that school in the particular state? And by the way, there's the state field in our public schools data set. We have a good 2-letter code state field that we're going to be using to generate our quality of scores, our weights. All right, so we have 107,000 in the United States, 107,299 public schools. Here's a list of private schools, again, downloaded from the Homeland Security webpage. And so again, similar data, but, and again, over to the right, you can see, once again, enrollment, you can see starting grade, ending grade, and full-time teachers. How many full-time teachers do they have on site? So you can see where I'm going with this. Full-time teachers, 12, enrollment, 151. What's the student-to-teacher ratio? All right. And then the other factor I thought would be important would be the number of schools. So in other words, if you have to drive 20 miles to get to a particular school that you're interested in, that's not going to be a very good quality of life. Day by day, driving people back and forth to school can be a chore. So the amount of schools also, the quantity of schools was also a factor that I wanted to consider. All right, so the count of private schools that we had are 22,615. So interesting. Public schools in the United States, 107,000, almost a 5-to-1 ratio between the private schools that were listed. Moving on to crimes, our input crime data. This was some good stuff. As you can see, we have it by 1979 all the way up to, I believe it was 2020. And you could see for each year, we had a population of the state, followed by how much violent crime was reported in that year, how many homicides were reported in that year, rapes, robberies, aggravated assault, property crime, etc. So looking at this, I kind of said, well, there's a type of crime that affects lives. Every crime is not good, but there's some crimes that are worse than others, of course. So crimes that are violent, crimes that are homicides and rapes, those are crimes that we can put them into one category and say, okay, those are crimes that I want to kind of avoid if I'm looking for a good quality of life. There's other crimes like robbery, property crime, burglary. They're annoyances, yeah, and they happen, but how much of a weight do you want to have in your quality of life? You know, in the bottom line, you know, you could say, look, I don't want any crime where I'm going to be living. So, but you could kind of tailor it a little bit if other qualities pop up that are conducive to where you want to go and say, well, okay, there's not a lot of violent crime, but there's some property crime I have to be aware of. So again, you tell yourself to put in a better security system and so on. This data set I did not use. This was a violent crimes data set that I downloaded, and I just gave it as a resource. So you could use this also if you wanted to add it to your challenge. But I didn't really include it and add it because it was only for a single year. I believe this was for 1973 or something like that. So it was a pretty limited data set, but I just wanted to show you that there's other forms of crime data that you can download. Here's mortality. Mortality by all the way from 1980 through the years, all the way up to 2014. Yeah, 2014. So a good span of mortality rates between 1980 and 2014. And the data was just about ready to roll. I mean, look, you had the category of mortality, and then you had the rate of mortality, and then it was, but the other, it wasn't by state, it was actually by county. So there we brought in another data set to help us convert this data set from county records into state records. And the key to this was something called a FIPS code. So by reading this FIPS code, we could use ECL to go in, grab the FIPS code, and convert these county locations into their valid state code. All right, so we had this mortality here, and then we also had mortality by state. So this was another data set that I downloaded at the 11th hour for the students participating in the challenge. And I said, here's another mortality file that you can also use if you wanted to add it to your scoring system. All right, and 627,000 records. So it was quite a good extensive database for measurement. Finally, getting over to weather. So weather was interesting because the weather data was in storm events, storm fatalities, and so on. So we downloaded year by year. And since each year was a consistent record structure from the weather website, we were able to very easily make a composite file of this by just creating a super file. So this is the only data set that I needed to deviate from a little bit, from just a straight data set to a special data set that was using super files. It was a very easy process to do that. And I decided just for this challenge to just import the last 5 years of weather events from 2021 back down to, I believe, 2017, 2018. Okay, and then this was the FIPS lookup table that I was referring to that converted the county code into the actual state code. So remember, now in the FIPS code, you have the first digit being the actual state and the last 3 digits being the actual county code. So all we needed to do was to parse in the first number of the FIPS code, and then that would give us the name of the state that we were going to be using. So we used this in the mortality data set that we were working with. All right, so that's the input data. And do you notice I do spend a lot of time talking about the data coming in because, hey, you know, rule number 1 when you're working with ECL, when you're working with any data project, is to understand the data you're working with before you start to write the code. So this is a good work unit here for you to study, to check out the data, look at the data, and maybe you'll get some additional ideas other than the ones that I'm going to be presenting to you right now. All right, so again, we're back on education. So let's talk about building schools first. So here we have some ECL code, and you'll notice that studying the record structure for the public schools and studying the record structure for the private schools, the records were almost identical except for 2 fields. The private schools had a special field called FID, I guess it was federal ID, and the public school had a field that was unique called district ID. So I took that as kind of an easy way of identifying one record as a private school and one record as a public school. If the record had a valid FID, then it would be a private school. If it had a valid district ID, it would be a valid public school. So there's a couple of projects going down here. You see that I'm just looking for the FID, and if the FID was defined, if the district ID was marked as private, I was doing some transformation here. So this was actually adding the word public to the public school records. And then this project here was adding the word private to the district ID field. So remember, I was using the FID field for public schools, and so I might have had that reversed when I was talking about it up above, and the district ID was private. Then I do one more project to add both public and private together. All right, then I sequence the records by using the built-in counter of the project. I output it to a file that I'm going to use later on. And then while I was there, I decided to analyze my output and give me the best record structure, which then I turned around and used in this module called file_all schools. So remember, this was the record structure that I built by merging public and private together. So I created a brand new data set here, defined the data set. And then as you can see here, I can browse this. So there's some schools that are marked as public and some schools that are marked as private and so on. So you can see everything's working. And I added another field here to my all schools data set called public. And if the Boolean flag was set to true, then it's a public school. If the Boolean flag is set to false, it's a private school. So it made my logic a lot easier then. And why I was doing this is going to be explained here. So count of all schools, you can see 129,914 schools in the United States. Here was a sort by name, just so I could look at the data in another way. And so that was just a quick BWR file that was merging the schools together. Now, here is the magic, the analysis of the all schools data set. So I decided in my education category that 3 data points were going to be used. We're going to have, first of all, the amount of public schools, the amount of private schools, and then a private to public school ratio, and then also student to teacher ratio. So these were the data points that I pulled out from the all schools data set. And you can see I'm calculating a ratio percentage here in, again, a simple project with a built-in inline transform. Output it to my file, which I'm going to then score. And this was my result. So you can see I have now the state, how many schools in the state, how many public schools in the state for private to public school ratio, and then actually it should be public to private school. It's public schools outnumber the private schools 15-1. And then the average student to teacher ratio, 16 students for every teacher. All right, so now I've got my data points that I'm going to score. And the last thing I needed to do was build that scoring system. So I created 3 new fields in my record output here: a student teacher score, a private school score, and a public school score. So who has the best private state had the highest and best student teacher ratio. So once again, and this was just the ranking of the stuff that I already analyzed in the Analyze Schools BWR file. All this was doing now was looping through this information, building a table of only the data that I was going to be using, looping in descending student teacher ratio, and then assigning a score based on the largest student teacher ratio is actually not good, is it? So if I had a 200-1 ratio or a 300-1 ratio, then that score is going to be the lowest. It's going to be a score of 1. And all the iterate was doing here was just, in the event by chance that my ratio from one state equaled the ratio of another state, then I would then keep the same ranking. So if they had the same result, I'd keep the same ranking. If the results were different, then I would increment the ranking from 1 to 2 or from 2 to 3 and so on. So I did the same thing for student teacher ratio. I did the same thing for private school count. Now, by the way, descending student teacher ratio was the higher ratio was bad, but in this iterate, we're sorting by. So the greater the amount of public schools and private schools, the higher the score. So once again, in this case, lower was proportional to a lower score. Lower amounts of private schools and public schools got a lower education score. And I put all this into a file called education scores, which we're going to use later. All right. So education done. Now let's talk about crime. Crime was a lot simpler. Here was the source of the crime data that I downloaded. Once again, between 1979 and 2020, it was just a made-to-order, beautiful data set called estimatedcrimes.csv, and it was already sorted by state. And so there was a lot of data in here that I could draw on that was great. And unfortunately, the FBI phased this one out. So you can still get crime data after 2021, but there's different formats now that you have to deal with and merge. This was just beautiful because it was all in one package and ready to roll. So I decided just to go with that one, 1979 to 2020. And so the data was almost ready to roll. So all I really needed to do here was just the analysis of the crime data and then the building of the crime scores. So once again, let's take a quick jump over to our first BWR file called Analyze Crime. And you can see up here that I'm doing some cross-tab reports by population by state, violent crime. Remember, because we're going from 1979 to 2020, so I was breaking by state abbreviation in my crosstab report, so that now we can group this statistic by state by state by state, composite over all of those years. So we are rounding off the violent crimes, we're rounding off the homicide for all report. We then run that into our scoring system. And the one thing I discovered here was the first output, which is the original average of all years. When I started to do a percentage, the numbers were coming out very small. So I decided to bump it up a little bit mathematically. And as long as I bumped up all the categories, it was consistent. But you can see, like, if you take 45 homicides in Arkansas out of 617,000 people, well, then, you know, that, by the way, that's 45 homicides a year in the state of Arkansas. Whereas you think, oh, well, Alaska is a lot worse, 391 homicide average, but look at the average population over the years was 4,405,000 and so on. All right, so we built our crime ratios. I bumped up the numbers so that we have something that was more measurable. And then after building these ratios, it was a simple matter of building the scoring. And what did I pick for crime? Well, what I decided to do, instead of going nuts with each individual category, I decided to consolidate all the violent crimes into a violent combined ratio, violent crime combined ratio, and then property crime combined ratio. Right, so these are composites of all the violent crimes, which I deemed as violent crime ratio, homicide ratio, rape, and aggravated assault. So I built those ratios and decided that's what we were going to do to measure the crime scoring. So you see, I have a violence score that I assigned, and then I have a property crime score that I assigned. So those are the two data points that I used for crime. And so here are the crime scores and the rankings. So you can see DC was ranked #1 in both violent crime and property crime, although it's not a real state. Arizona was 16th in violent crimes, but 2nd in property crimes, and so on. So this was building my scoring system for the individual states. All right, so that's education and crime, and let's go to category number 3. This one's dear to my heart. I wish I could live forever. Life is so good, and you know, I love what I'm doing. I love presenting these workshops to all of you, and I hope to do it for many, many, many years to come. So mortality was an important thing to me. You know, how are people living in where they're located? Does it really make a difference? And it kind of did, you know, when you look at the data sets that I'm going to show you. So there are 2 data sets. I used the one up at the top here, mortality by county. That was the first one I got, and I liked it because it was a deep reference of mortality from 1980 up to 2014. Later on then, as we're getting close to the workshop, I found another data set that was also pretty good, because this one actually broke it down by state, but also broke down mortality by race and gender. So if that's important to you, if you know, race and gender are important statistic for finding your paradise, you could also work in this data set. I did not do anything with this data set. The data set I worked with was mortality by county. All right, and there's our little guru and little guru's friend there, which I had to kind of censor because he was getting a little rude in that picture. So I finally, you know, just to make this workshop PG, I had to put a little disclaimer there. So let's talk about health. So the first thing we had to do, working with the county mortality data set, is I had to add the state information to it. So convert the county information to state information. Then once I got the state information, then I would do the aggregates for the state for scoring. And then again, cross-tab mortality aggregates and get the averages. So there was only 2 files involved in health, analyze health, and then build my health score. So let's analyze the health. As you can see here, I brought in the FIPS file, which was our lookup table that was then using a join. Hey, we have a join in the picture now. We've been talking about projects and iterates, and now we have a join that was used in this challenge to link our mortality file called life to our state FIPS table. And by the way, that's a local definition up at the top. So my mortality file was called the life file, and there's a life record that's exported, and then there's also my state FIPS lookup table. So I joined looking for the matching FIPS and the matching state code. And so I have this first output here that's called state added. So you see I added a state to all the mortality records. And then I said, let's cross tab this and let's merge them all into a single record and pull in all of the mortality rates. So you can see here that this was an average mortality that we were, I'm sorry, up at the top here, we were just, let's see, this one right here, state only, was again doing a join to pull in the mortality records and then adding the state field to our mortality records. And then finally, then we worked with building our scoring factors. And I decided, because it was made to order, change in mortality rate from 1980 to 2014. And so then what was the maximum mortality rate? What was the minimum mortality rate? So I did a rounded and average there. And so I've got the sum of all mortalities over the years, and then the maximum at any one particular year and the minimum at any one particular year. And then I wrote that out to a file called main hacks mortality. All right. And then finally, I took that mortality data and then scored that. So as you can see here, I created something called a mortality score. And once again, this was the ranking. I was just purely going by mortality score, and mortality score here was sorting by the sum cumulative. So I changed kind of courses in midstream here. I originally thought that maybe max and min would be an important data point, and then I kind of backed up on it a little bit and said, well, let's just go with the cumulative sum of mortality rates over the years between 1980 and 2014. So I built a mortality ranking here from 1 to 50. Here's the states. You can see it's not good to live in West Virginia. Oklahoma had a low mortality score. Remember, lower is worse. The higher the score, the better the mortality rate. Mississippi, not too good. Arkansas, not too good. And by the way, this gave me an interesting statistic that I'm going to show you at the very end. So that's mortality. And we're almost home. The last thing was weather. And as I told you, the weather, what I first did with the weather was from the National Centers for Environment Information, NOAA, National Oceanic and Atmospheric Administration, downloaded the data from the years 2018, I believe, to 2022, although I could have gone back to 1950 if I wanted to do that. And I did that, so I encouraged people, if they wanted to get more weather data, if weather was more of a factor, how did that affect scoring? You know, so the idea here was, I want to live in a place where there's not a lot of tornadoes. I want to live in a place where there's not a lot of violent storm events, and even more so because they do measure fatalities. So when weather causes death, that can be measured. That can be measured by NOAA year by year by year by year and state by state. So it was an easy effort here to just simply combine the data sets into a single super file. That was step number one. So I had this file called file_weather that merged all of the yearly storm event data into a super file that I can just reference with one data set statement. Next step, step number two, we sequence the records and then add state to the weather. Cross tab by the state, get a weather event count, create a severity code. Now, by the way, here's another thing that I kind of backed out on a little bit because I didn't want to go too far. These examples that I'm showing you in this workshop were done as examples to give the students kind of a springboard into their own examples. A lot of students took what I did and then they added to it a little bit. Some people started from scratch with their own project and so on. I originally thought that maybe a severity code measuring weather events like how bad is a rainstorm, maybe not so bad, but how bad is a flood, a lot worse. So there was severe, you're going to see in my code that I'm going to show you this analyze weather, that I was originally looking at severity codes, and then I kind of backed off of it a little bit and said, well, let's just go with something a little bit easier to work with. All right. So let's go into the weather. So we have here, okay, I did health, okay, let's go into weather. So the first file here that we have is called analyze weather, and then build weather scores. All right, so let's look at analyze weather first, and then we'll look at building the weather scores. Okay. So once again, the original super file, which I'm calling storm data. All right, at the very top, I'm adding state now to this data. Actually, let's run this so you can see the results while I'm talking about it. So we're projecting through the storm data, we're transforming it, we're adding state information to each record that is needed. And then after adding the appropriate state information, let's take a look at that. There it is. So we have Arkansas, the event type, how many events for that particular type, and how many deaths, how many injuries for that particular type, and so on. So as you can see, the state of Alaska had blizzards and hail and high wind, and Alabama had wind chill, excessive heat, flash flooding, frost and freeze, and so on. So all of this data was then aggregated together into, well, here we had the severity code that I was working with. And I decided, I think I backed off of this and said, well, I think that's a little bit too much right now. I think I can just go with weather events. So this is what I ended up with. I ended up doing by aggregating using crosstab reports, how many events happened for the state, how many events were fatal, how many events involved injuries. So the nuisance weather, I kind of just sidestepped a little bit, and I said, I think in this case, weather fatalities and weather injuries are more important data points. And of course, the amount of events per state. And by the way, remember, this is over a 5-year period. So you could actually expand this data and get a more rich result by adding more years to this weather data set. All right, so as you can see here, I was doing a join to pull in the state information using that FIPS table again. And then I was doing a crosstab report down here of how many events by state, and then also doing a sum crosstab of all of the injuries by state and a sum of all of the deaths by state. And by the way, the weather data set had direct injuries and indirect injuries. So in other words, the weather itself didn't directly cause the injury, but maybe at the end of the event, people were picking up trash and they fell and broke their arms. So that's an indirect result of the weather. So they did measure that. And indirect deaths, and during a hurricane, you could die during the hurricane or after the hurricane. People go out and walk around and step on a power line and they get shocked, and there it is. That's an indirect death. So we built, for the data points for weather, we built the count of events per state, injuries, and finally the deaths, fatalities. Built the weather scores, again, as you can see the similarity in this code, iterating to rank properly, and the ranking was done by descending events, descending injuries, and descending fatalities. So there were 3 data points that I used in my scoring. All right, now let's take it all home. Let's take these 4 data sets, education, crime, mortality, weather, and let's merge them together into a composite Find Your Paradise score. And then let's deliver the data to our customers by building an index and deploying it to ROXIE. So this last part here, we decided, well, we could look at the composite record that it decided on, and you'll see here was the information from the crime. Here was the information from education. Here was the information from the mortality. And then here was the weather information. And I created a composite record. And you can see here, I left this in here just to show you that, you know, the beautiful thing of working with data can be, you know, a changing process. So you see, I had all kinds of stuff planned into this composite, and then I decided, don't go nuts. Let's just keep it simple to show them the example of what's going on. So you see, I had in here, I was planning to include maybe the violent crime ratio and the homicide ratio and add that to my Paradise score, but then I decided to simplify things. So I did that, and I did that for mortality and weather. So there it is. There's the data set. I defined the data set. I defined the index that I then would build to deliver to ROXIE. So I'm going to calculate and sort by this thing called a Paradise score. So let's talk about how we get to this Paradise score. All right, and here it is. You can see all I'm doing is a series of joins. I started with the weather data, joined it with the crime data. Then I took that result, merged crime, joined it with education data, and then one more join, because remember, all the scores have already been calculated with my build education scores, build crime scores. All I had to do was put them into one basket. So I took all the education scores and health and so on, and I did that. I'm going to submit this to just show you the result. Whoops. I don't know what that was. All right, so you see, adding the weather information. So you can see there is the state and weather information on the far right side here of this output. Then I added crime data. And so now you can see there's the crime data and there's the weather data. Then I added I added education to, and then finally the last one was mortality. And so here was the composite result. And along the way, I calculated, ta-da, the Paradise score. So the higher the Paradise score, the better place to live. All right. So we're almost at the end of our hour. So how did I deliver this data to the end user? So data delivery, we used ROXIE, and I also gave an option to the challenge for people, and if they didn't want to go the ROXIE route, they could use visualization to demonstrate their statistics. So in other words, they could show the United States and say, look at these states, this is a good place for crime, this is not a good place for crime, and so on. Here is the United States, here's a good place for mortality. So they could have broken it down in individual categories, and they could have presented their data category by category. But also, ROXIE was a good option there. And so what I did was I created a service called Find Your Paradise Service. And because of the multiple parameters, I actually created something in ECL called an interface. I published to ROXIE, target, compile, publish, and test. All right, so actually, before I wrap up with that, let's take a look at that service. So first of all, there was in this repository an interface, and these were the final data points that I chose to present to the end user. Is a student-teacher to ratio important? Is a public school count important? Is the number of private schools in the state important? Is violent crimes a good factor in your quality of life? Is property crimes a good factor? Is longevity, mortality an important factor? And then weather events. You don't like weather? You don't like to be injured by weather, or you don't want to die by weather. So I gave you that level of selection. Or you could be selfish and just say, I want it all. So just measure everything and show me what's the best place to live in the United States. So that interface was used in my service. By the way, if you've never used an interface, I would strongly recommend it, not only in ROXIE delivery, but also in functions that have a lot of parameters. You can wrap it around an interface, and then in the function itself, you can simply reference the name of the interface, and all of the parameters then are readily available. So you see, I've got a function here called find your paradise. And what I actually did then was I had, if they had clicked on student-teacher ratio, I included that score. If they included public schools, I included that score. So I calculated a paradise score on the fly based on their selections in the ROXIE interface. Or if they said, I want it all, then I just read the index that was built, the paradise score that was built and stored in the index. So I had the paradise index, but then also I could calculate new indexes on the fly based on what parameters they were selecting. All right, so the idea behind this, and most of you know how to do this, you change your target to HTHOR or ROXIE, then you issue a compile only. The compile, instead of giving you the green check mark, it'll give you a green circle. So you see, if you zoom in on this, you see a green circle. I go into the ECL watch, and here is the publish option. And so all I do was publish this to my cluster. I've already published this, so I don't need to do it again. And I will show you now the end result of this service. All right, so you can see when I zoom in on my cluster here, you'll see there is a service called Find Your Paradise. Go into the test pages interface. And I'm selfish, I want it all. What's the best place to live? And Virginia came up with the highest paradise score. State of Virginia, followed by Maine, followed by New Jersey, followed by Connecticut. At the bottom of the list for everything, all those 4 factors I considered, the bottom of the list was Louisiana, Nevada, Oklahoma, and Tennessee. And that's interesting, Tennessee, because I did some work one time at a company, Deloitte & Touche. I was doing training there, and they lived in Hermitage, Tennessee, and they moved their entire operation from New York to Tennessee. And I said, why did you do that? And they told me, well, taxes were better in Tennessee. So remember, we didn't consider money. We didn't consider money in our Find Your Paradise. So that might be another data set that you might want to include in your paradise score, would be the amount of taxation that goes on state by state and how much out of pocket you're going to have to pay living in one state versus another. Since I didn't consider taxes in this one, Tennessee ranked pretty low as far as crime, mortality, health, crime, mortality, education, and weather. A lot of tornadoes in Tennessee. All right, so again, testing my query one more time here because we're running almost at the end of our hour here. I go in and I say, I want to live longer. My longevity is important to me. And also, I don't want to be in an area where there's a lot of violent crimes. And I don't want to live in an area where weather is killing people. So I got very selective here. Longevity, violent crimes, weather fatalities, submit, calculate the new score on the fly. And according to my paradise, I should be living in Vermont or Maine, one of those New England states, and Virginia was ranked 3rd. Hawaii popped up. That's interesting. That might be better. Move to Hawaii. Okay, so you get the idea here. This query will be on is on the cloud cluster, so you can go out there and fool around with it and find your paradise. All right, one last thing before we wrap up, and that was the other option for our students was visualization. So this slide right here just goes through the different types of visualization that is available in the ECL Watch and ECL, and built in via the visualizer bundle. Now, I want to tell you, I just tested this prior to the workshop, and the latest Client Tools version that I had loaded on my machine was 9.2.4. And I will verify to all of you out there that the visualizer bundle installs correctly. Now, I got a message that told me it was already installed, but it did reach the GitHub repo. It found the visualizer, and it gave me a command error of 0, which means no errors occurred. And so the bundle install was working correctly for this version of Client Tools. And I'm just mentioning that was because there were some Client Tool versions that were not working correctly. I can verify that 9.2.4 is working beautifully, and other versions as well in version 9. So visualization examples, I'll leave you with this. We have one more example to show you, and that is the state choropleth. So by importing the visualization bundle and then simply calling this choropleth of US states, generating a crosstab report of mortality. So just show me the mortality score by state. And actually, it wasn't even a crosstab report. It was just a table of mortality, and then graph it. And all I did here was just change the color of my graph to purples. So all of this is documented in the visualizer bundle. So with just 3 lines of code, I was able to generate something like this. So here you see the United States. This is an actual graph of mortality. And boy, did this make me think. When I looked at this graph, I said, okay, so the more populous states like California, New York, states on the East Coast, people live longer. People live longer when they're near the ocean, all right? Not so much for the middle of the country. So Ohio, Indiana, West Virginia being the worst, by the way, Kentucky, all this whole area here, I would want to research this a little bit more. I'd want to know, why is the mortality level in these states lower than in the states like New York and California and Florida and Georgia? So other statistics, other analysis here, this intrigued me to go. Alaska, a lot of people live long in Alaska. That's good. More than Hawaii. Hawaii 27, Alaska 47. People live longer in Alaska than they do in Hawaii. Okay. And that, folks, as they say, will do it. Once again, I take you to Wally the Wonder Dog, who helped me with this workshop. And there is my email at the top and Richard Taylor's email at the bottom. If you have any follow-up comments or questions, please email us directly. Also, we'll be answering all the questions in the chat that we haven't already got to. And that will do it for hour 2. We will see you tomorrow for hour number 3, which is a dive into relational data sets in order to give us better customer insights. So everyone, enjoy the rest of your day. Thank you for listening, and we'll see you tomorrow.